With so much material available online, it's easy to find joystick control code without really knowing how it works. But that's no good if you're trying to modify it. This video will help you understand where that code is coming from. Imagine we have a robot as shown and we want to program single joystick controls for it. Now let's think about what that means. It means that if we push the joystick forward, we want the robot to move forward. If we push the joystick to the side, we want the robot to turn, and backwards should make the robot go backwards. In other words, the y-axis of the joystick controls the forward and backward movement of the robot, which is given by the sum of the power on each side of the wheelbase, whereas the x-axis controls turning, which is given by the difference between the power on each side. Now all that's left is a little algebra. We want to solve for the power on the left and right hand sides of the drive, L and R, in terms of the position of the joystick, given by x and y. As you can see, the solution is pretty simple. Now we can plug this solution into our code. In robot C, we get the x position of the joystick with channel 1 and the y position with channel 2. Here you can see the one-stick controls in action. It can move forward, backward, turn in either direction, and move forward or backward while turning. Now let's apply this technique to a more complicated holonomic drive. In a holonomic, each motor, let's call them A, B, C, and D, pushes the robot in the direction shown. Now a holonomic drive, or a mechanism drive, since the two are essentially equivalent, can move in all directions and turn. So we probably want one joystick to control the movement and the other to control the turning. Now let's examine each axis of the joysticks again. The y-axis of the left joystick controls forward and back movement, which is produced by all four motors working together. The x-axis of the left joystick is responsible for side-to-side movement. Motors A and C push the robot to the right, working against B and D, which move it to the left. Finally, the right joystick controls turning. Motors A and D turn the robot clockwise, working against B and C, which turn it counterclockwise. Right now, we have 4 variables and only 3 equations, so we need to think of another constraint. A good idea might be to ensure that the total power provided by the front 2 wheels equals the power provided by the back 2 wheels, so that when we're moving forward, no wheels are dragging behind. Now we have a system of 4 equations in 4 variables, which we can solve using matrices. You can see we're giving the power for each wheel in terms of the position of the joysticks. Again, the conversion to robot C code is pretty straightforward. Here's how it looks when we apply that code to a standard mechanism drive. Hope that was helpful.